Get this on one line. I don't like this. Okay, guys. So like I said, we're starting day one today. We are not going to, so no homework tonight. You will have homework on Friday. The amount of days in it actually on the syllabus are not that long, but I think each day takes like 1 or 2 days, so it's going to be longer than what the syllabus says. Okay, so we're going to start off today by graphing exponential functions, and what makes a function exponential is when there is a variable as the exponent. So let's write that out. Oh man, it's already freezing my computer. Let's see. Here we go.
How did you be the first person who ever tied their hair about? They didn't see for an house. Like they were like, when it was off for the
Okay, an example of an exponential function would be something that looked like f of x is equal to b to the x. And now there's going to be a restriction on this. B must be greater than 0. And write that down, and then we'll talk about why. So if I'm saying b, the base, must be greater than 0, that means I can still have fractions, right? Because like a half is greater than 0, a third is greater than 0. We can absolutely still have fractions. I just can't have what kind of number? Negative. This is saying b must be a positive number. It cannot be a negative number. Let's talk about why it has this restriction. If b were a negative number, let's say b was -2, okay? And if I had b as my base is -2 and I raised it to the second power, would it be okay? It sure would. If I raised it to the third power, would it be okay? It sure would. But let's say I raised it to the half power. Would that be okay? No, raising it to the half power is the equivalent of doing what? Taking the square root. And if we take the square root of a negative number, what is that? Imaginary. So it's taking us out of the real numbers, and we can't be out of the real numbers. So that's why every exponential function has this restriction where our base must be greater than 0. Is there any restriction on the exponent? No. Can x be negative? Absolutely. That's not a problem. Okay, so now let's talk about parent graphs of exponential functions. All right, there are 2 parent graphs. The first parent graph is y equals 2 raised to the x power. In this y equals 2 raised to the x power, in this exponential, there is absolutely going to be an asymptote. How do I know there's going to be an asymptote? Because when I look at this 2 raised to the x power, our input goes into the x and our output is y, right? So if we put a number in for x, that gives us the corresponding y value. Well, is there any input number that we could input for x that will pick out a 0 in this equation? There's nothing. Even if I put in 0 for x, what's 2 to the 0 power? 1. There's nothing, no number, positive or negative, fraction or whole number, that I can input for x that will yield a 0. So that means this whole function will never cross what? Y equals 0. So there's absolutely going to be a horizontal asymptote at y equals 0. And now there's something called a key point. And so the key point for our parent graph is when I input a 0 for x, no matter what number this space is, whether it's a 2 or a 5 or a 500 or a 1 over 500, no matter what number the space is, anytime I input a 0 for x, what will always be the output? 1. So that's why for this parent graph, our key point is going to be the 0.01, because no matter what my base is, when I input a 0, I'll always output a 1. So those are going to be two main parts of our exponential function. So we're going to say key point zero, 1, and a horizontal asymptote y equals 0. And so this, a sketch of what this graph looks like. I have my horizontal asymptote at y equals 0. I have a key point at 0, 1. And what happens is I hug this horizontal asymptote, and then I hit that key point, and then I start sort of growing exponentially. And this makes sense. When you have an exponential function, it grows at a very, very quick speed. It increases at a very high speed. Because think about this. If I have even just 2 to the second power versus 2 to the 10th power, isn't 2 to the 10th power so much bigger than 2 to the second power? So it grows at a very quick speed when you have a variable in your exponent. So that's our first parent function. The other parent function is going to be y equals a half raised to the x power. So the 0.01 was a key point because we were saying no matter for our parent graph, no matter what the base is, if I input a 0, I'll always output a 1. Does this have the same key point? Yes, it has that same key point of 0, 1. Does it have the same horizontal asymptote of y equals 0? How many people say yes? How many people say no? Okay, so how did we figure out that there was a horizontal asymptote at y equals 0 here?
Becca, because there's nothing that x can equal to that would make y 0.
Perfect, because there was nothing that we can input for x that would make y 0. So we know what y will never be 0 in any point on this graph. So we have a horizontal asymptote at y equals 0. So we'll write this out. We have the same key point. We have the same horizontal asymptote.
Wait, can you explain this thing like
So for the parent graph, the key point is always 0, 1, because in our basic format of an exponential, it's some base raised to a variable exponent. So no matter what our base is, if I raise it to the 0 power, it's always going to output 1. So that's why it's our key point, because we can change the space to any number and it's still going to output a 1 when we input 0 for x. Okay, so horizontal asymptote at y equals 0, key point at 0, 1. Okay, but now let's think about this.
Is the x squaring the 1 or the? Oh, okay.
like it's
Yeah, I get it.
There's the parentheses. Okay, so let's see what's happening here. If I have 1 to the second power, I'm sorry, a half to the second power, isn't that 1/4? if I have a half to the third power, isn't that 1/8? So as x is getting bigger, my y is getting what? Smaller. So as I move along my x-axis, my y could be getting lower and lower and lower. So when my base was a whole number, wasn't I increasing? But when my base is a fraction, guess what? It's decreasing. So it's an exponential, but it's now decreasing. So what does this look like? We come from the top, hit our key point, and then start decreasing the whole way down. Okay, so now what we're going to do is talk about now shifting this key, shifting these parent graphs. So let's say I have now my format for shifting is going to be y is equal to b to the x minus h plus k. And I'm staying consistent with all of my other shifts. And every other shift for all of our other like tonics and things that we were graphing, the h shifted what? The x, and the k shifted the y. So h was our horizontal shift, k was our vertical shift, right? So this absolutely does the same thing. So what this is going to do, h is going to represent our horizontal shift, of key point, and k will represent the vertical shift of the key point. And for both of these, the key point is based on the parent graph. And then I'm going to put a star. And I'm going to say there's going to be a horizontal asymptote one unit below the key point unless there is a number in front of the base. I will never give you one where there's a number in front of the base, but this is something we should know. So an example of this would be, let's say I have y is equal to 2 times a half raised to the x power. I shouldn't write a number in front. I should say a number multiplied with the base. Okay, what does this mean? So if I were to ignore this 2 right now, this is a parent graph, right? A half raised to the x. Can we agree if I'm ignoring this 2 that my key point would be the 0.01? And then I would have a horizontal asymptote based on what I said 1 unit below that. So I have a horizontal asymptote at y equals 0. This number being multiplied in front changes everything. Because when I now have that number in front, say x is 0, I'm going to input that 0. This is going to be 2 times a half raised to the 0 power. Well, then I have a half to the 0 power is 1, but 2 times 1 is 2. So now my key point is the 0.02. But my horizontal asymptote is not actually y equals 1, because based on what I said is there's always a horizontal asymptote 1 unit below the key point. But there is not a horizontal asymptote at y equals 1, because my horizontal asymptote is still at y equals 0, because there's still nothing that will yield this whole side to 0, right? No input for x that will give me a 0. So there's still going to be a horizontal asymptote at y equals 0. So it looks something like that. Okay, just an idea sketch. Now, for the purpose of this class, I will not give you problems where there's a number in front. Right, we're just going to strictly keep it to parent graphs and the shifting H and K. That's all. But I did want you to understand that it's not always 1 unit below. This is the scenario if we have basically a number in front that's multiplying with the exponential. That will change that rule. All right, let's do some sketches. Yes, this chapter. So we're doing exponential. Logs are directly related to exponentials. So today I'm explaining exponentials. Next class, I'll show the relationship between the exponential and the logs. All right, so here we're going to do some sample problems. I want us to sketch. First one is going to be y equals 2. Hey, Jerry. Which one do I want to do? We want to do y equals 2 to the x minus 3 minus 1. There we go. Okay, so first thing I need to know is this exponential going to be increasing or decreasing, and how do we know, Stephen?
Increasing.
Perfect. Increase because my base is a whole number. It's not a fraction. Now, my parent graph, the key point would have been the 0.01. I'm going to make some graph paper here. Okay, so for my parent graph, my key point would have been the 0.01. Now, looking at the shifting, my h is 3 and my k is -1. Do we agree? So now I'm going to take that key point and where am I going to move it? 3 units to the right and 1 unit down. So now this new blue point is my key point. And based on what I said before, once I identify my key point, I'll always have a horizontal asymptote where? 1 unit below the key point. So here's my horizontal asymptote. Must I make that horizontal asymptote dashed? Yes. Okay, now do we also agree that the key point is my x-intercept? But because the asymptote, the horizontal asymptote is below the x-axis, I will also have a y-intercept. So I'm going to find that next. I'm going to find my y-intercept. So we're going to plug in 0 for x. So we're going to have y equals 2 to the negative third power minus 1. Y equals 1/8 minus 1. So that's going to be 1/8 minus 8/8. So y will equal negative 7/8, which is going to be about here. So now this looks something like that. And like I said, it's just an idea. It's just a sketch. It's not going to be perfect. Okay, so let's identify some things. My key point has now shifted where? To what point? 3, 0. We had a horizontal asymptote at y equals negative 1. What is my domain for this? All real numbers, perfect. What about the range? Stephen? Negative 1, comma infinity. Now, am I having brackets or parentheses here? So you think it looks like this? All right, I'm going to say you're right on the infinity, but we're wrong on the negative 1. Could you tell me why we're wrong on the negative 1? No, it's still negative 1. Your number was negative 1. That was correct. Your bracket was wrong. Just feet? Good. Because of the horizontal asymptote, we're going to get really, 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 really close to that negative 1, but we're never going to cross it. Okay, couple of things before we do any more graphs, couple of things I also want us to go through. Let's see. 2. If I have y equals b to the negative x, I want us to recognize that this is the same as saying 1 over b to the x power. Why? Why is this happening? Because if I have a negative exponent, in order to make it positive, can I just put it into the denominator? Why is it important for us to recognize that b to the negative x power is the same as 1 over b to the x power? Exactly. If you take a quick glance at this and don't really register that exponent, you'd be like, oh, it's a whole number base. That means we're going up. But because of that negative exponent, it's not a whole number base. It's a fraction base, which means we are decreasing. Guys, don't write on my table. Okay. The inverse of this is also true. So let's say I have y equals 1 over b raised to the negative x power. That's the same as saying b to the x power. The next thing is if I have y equals negative b to the x. You don't have to write this down, but just to show you, let's say I have y equals negative 2 to the third power. Oh, no, I don't want the third power. That will change the second power. How many, our two options is this is negative 2 times negative 2 versus do we agree these are two completely different answers here? How many people think this negative 2 to the second power is represented by this first expansion? How many people think it's represented by the second expansion? Okay, it is the second expansion. Why? Right now, this exponent of 2 only belongs to the 2. If I wanted that negative included, what would I have had to do? We would have had to put parentheses around it. But because there's no parentheses around it, is that negative getting the exponent? No. Why is this important? This is important because for this one, this is going to be y equals the negation of b raised to the x power. So remember I said our base can never be negative, but is this a negative base if I put a negative in front of it? No, the base isn't negative. So what is this saying to do? This is saying graph your exponential and then negate it. Basically, we're graphing our exponential and then negating the x. When we're negating the x, let's say I have the point 1, 1, and then I negate the x, I have the point 1, -1, right? Or negating my input for x, whatever. What is that the same as doing? Reflecting over the x-axis. So this is the same as reflecting over the x-axis. So it's really saying put your input in for x, whatever you get, then negate it. That's the same. So really we're negating the y, right? So that's the same as reflection over the x-axis. Okay, so one more thing I need to tell you. Is it? Sometimes we're going to have base of e. And e is going to represent an irrational number that's approximately 2.718. Okay, so I'm going to, for your purpose of this class, all you really need to know is that e is a number greater than 1. All right, for the purpose of you, we only need to know for this class, e is a number greater than 1. But I do want you to recognize where this e, this approximation is coming from. So e is defined by the limit as n approaches infinity of 1 plus 1 over n raised to the n. And what this means is this expression, as I'm getting bigger and bigger and bigger and bigger. So it's not a certain number plugging in for n. It's just saying, as I'm getting bigger and bigger and bigger and bigger, what is happening? What number is it trending towards? Where is it heading? So if we wanted to set up a chart and plug in different numbers for n, so let's start off with 10, and I have 1 plus 1 over n to the nth power. This would be 1 plus 1 over 10 to the 10th power. That's going to give us 2 point, I already did this ahead of time, so that's going to give us 2.593. If I plug in 100, I'm going to get 2.704. If I plug in 1,000, add an extra 0 there, I'm going to get 2.716. If I plug in 10,000, I'm going to get 2.718. And sorry, guys, it's an irrational number. So the numbers keep going after that. It doesn't just stop at 6 or 8 or whatever. It just keeps going because it's an irrational number. If I now plug in 1,000,000, and that's a big jump, do we agree? From 10,000 to 1,000,000, you're still at 2.718 numbers after that. So what is this telling me? This is telling me what number do I keep approaching? 2.718. All right, so that's what this number represents. So E represents approximately 2.718. And like I said, why does this matter to you for this class? We just need to recognize that E is a number greater than 1. Because I can ask you to sketch y equals e to the x. And if I ask you to sketch y equals e to the x, and you don't know what e represents, you wouldn't know if we were decreasing or increasing. But since e is a number that's bigger than 1, what does that mean? We are increasing. Do we still have the same key points and all that good stuff? Yep, absolutely. So my key point is 0, 1, horizontal asymptote 1 unit below that. Okay. So let's do some more sample problems. I'm going in a weird order. All right, let's sketch this one.
I do. That's a good thing. Yes. I mean, is it possible to develop? I don't know how to specifically.
Okay. Is this a negative base? No. What is this saying to do? Stephen?
Get really amended.
Excellent. So what this is saying to do is we'll take your graph of the exponential 3 to the x power and then negate that. But when we're negating it, essentially what are we doing? Reflecting it over the x-axis. So what does this look like? I have my key point at 0, 1. I have my horizontal asymptote 1 unit below that. Am I increasing or decreasing? Increasing. So now this is my graph of y equals 3 to the x. Now to negate that, we're reflecting it over the x-axis. So instead of the point 0, 1, I have the point 0, negative 1. I hug here and then go down. So my answer is the green, not the pink, right? So it looks something like that. All right, 2 more problems and then we will call it a day. What do you think this is? This is absolute value, meaning it's going to be a V. No, what is this saying to do? Aditya? Say it one more time. Good. So first we're going to sketch 3 to the x minus 2, right? We're going to sketch our exponential. Then after we sketch the exponential, we have to make sure that everything y is positive. So meaning there can't be anything below what? The x-axis. So let's see what the sketch looks like. Have I shifted my key point? Yeah, we shifted that key point where? 2 down. And I'm going to have a horizontal asymptote 1 unit below that key point. So this is going to look something like this. So now I sketched 3 to the x minus 2. But now I want to take the absolute value of this. So that means y has to be positive. Can an input of x be negative? Absolutely. X can be negative. But our output, once we input the negative x and get whatever expression we get, we have to take the positive version of that, right? So y cannot be negative. X can be negative. Y cannot be negative. So where is everything y negative? Below the x-axis. So everything below this x-axis, we don't just poof make it disappear. We got to poof make it what? Positive. Everything below that x-axis we have to make positive. So now the point 0, 1, negative 1 becomes the point 0, 1. My horizontal asymptote at y equals negative 2 becomes y equals positive 2. Is it okay that my graph is crossing a horizontal asymptote? That's absolutely correct. Is it okay to cross a vertical asymptote? Never. All right, so now what I want to do is I'm taking this now whole section and I have to make it positive also. So it's basically reflecting it up. So that looks something like, let's go purple. This. And then I erase, oops. Oh no, why is it mad at me? Let's erase this first. Oh, well, I'll fix it. It was something like that. All right, so it looks something like that. We good? Last problem? We always finish so much earlier. I could have probably finished the lesson with this class. All right, last problem. This is not a normal exponential. How do I know that this is not a normal exponential? My exponent has an exponent. There is no shortcut to doing this. When you have something that does not look like your traditional type of graph, what we need to do is we need to plug in points or coordinates for x and find out what our y is. So I'm going to go -1. So then I'm going to have 2 raised to the -1 power squared. And if I have -1 squared, do we agree that's just 2 to the first, which is just 2. So now my first point that I'm plotting will be the point -1, 2. Now I'm going to do 0, plug in 0 for x. So we have 2 to the 0 squared. Well, what's anything to the 0 power? 1. So I have the point 0, 1. Now I'm going to plug in 1 for x. And do we agree we're going to yield a 2 again? So now I have the point 1, 2. And that's enough to figure out that it looks like that. Yes, it does look like that. So what's the moral of the story? The moral of the story is if it doesn't look like your traditional exponential that's just been shifted, you have to just make a table and plug in points. All right, this is where we stop. We will finish next class. No homework.